Assalamualaikum and hi. Today we will continue our lesson on subtopic 4.3 and we will discuss the answer for formative practice 4.3 on specific latent heat. Now let's look at the question. Alright, question number 1. Figure 4.23 shows an electric steamer. Explain how the fish is heated. Alright, this is the electric steamer, right? And at the base part we have water, and then we have the fish or the food on a plate, and it is in a closed container. Alright, these are the answers that I have prepared earlier, right? By boiling water continuously, causing the water to vaporize into steam. Alright, the water at the base of the steamer will turn into steam. Okay, knowing that the specific latent heat of vaporization for water is large, right, which is 2260 kilojoule per kilogram, right? Kilojoule, meaning it is times 10 power of 3. Now, the answer that I've been highlighted in red, okay, is the important notes that you must include in your answer, right? You must know that the specific latent heat of vaporization of water is large. And then number 2, on the foot there is plates, okay? Plates filled with food are able to absorb heat from the hot steam. Alright, now the plate itself will become hot. Alright, number 3, the condensation of steam at the base of the plate releases a large quantity of heat and thus enable food such as cakes, fish, eggs and others to be steamed, thus cooking the food. Alright, the condensation not only at the base of the plate but also throughout the steamer. Next question. Okay. Question 2. What is the amount of heat released when 0.8 kg of water at 25 degrees Celsius cools until it becomes ice at -6 degrees Celsius? Alright, now let us see, okay, the variables in the question first. Alright, heat energy. Alright, what is the amount of heat energy? So we need to find the heat energy. Release when 0.8 kilogram, this is the mass of the water. Okay, and then its initial temperature is 25 degrees Celsius and it cools until it becomes ice at -6 degrees Celsius. Alright, as it releases the heat energy. Now, state the assumptions you made in your calculation. Okay, what are our assumptions? Okay, we need to find the amount of heat release and we need to state the assumptions in our calculation. And then in the question itself, it given the value of specific heat capacity of water and specific heat capacity of ice, and then we can compare that the specific heat of water is much bigger compared to the specific heat of ice. Alright, okay, so specific heat capacity, if we recall from our previous lesson, okay, specific heat capacity describe the energy needed, okay, to increase the temperature of 1 kilogram of water by 1 degree Celsius. Alright, now it also given the latent heat, the value of specific latent heat of fusion of ice, which is 3.34 times 10 power of 5 joule per kilogram. So that is a big value there. Specific latent heat can be described as the graph of temperature against time. When water cools down, the graph plotted does not show an inclined line. Instead, it shows the pattern as shown on your screen. At the boiling points and melting points, boiling points at 100 degrees Celsius and melting point at 0 degrees Celsius, the temperature are constant even though the system releases energy to the surrounding. It can be explained that the energy were used for formation of new bonds. Before you answer this question, study the graph on the screen. The graph represents how the water changes from liquid to ice. Okay, from 25 degrees Celsius to negative 6 degrees Celsius. From the graph, we can see that there are two types of line, which is the orange line is an inclined line. Alright, for Q1, there is change in temperature from 25 degrees Celsius to 0 degrees Celsius. For Q2, it is a green line and it is a horizontal line. It shows that the heat released to surrounding when there is no change in temperature. And Q3, again, it shows the change in temperature from 0 degrees Celsius to negative 6 degrees Celsius. Alright? And then, for the inclined line, okay, it shows that the heat is released to surrounding. Alright, amount of heat energy release. Alright, we sum up Q1 plus Q2 plus Q3. So Q1 is MC theta 1, change in temperature. Alright, and Q2 is a heat, specific heat of vaporization, specific latent heat. And then Q3 is MC theta, right? And then we just substitute the value. Okay, the value of M, mass is 0.8. So C for water is specific heat capacity for water is 4.2 times 10 power of 3. And then change in temperature is 25 minus 0. And then the specific latent heat of vaporization is given 3.34 times 10 power 5 plus a specific heat capacity of ice is 2.0 times 10 power of 3, and change is in temperature is 6 from 0 to negative 6 degrees Celsius. And we have the answer here, right? 3.608 times 10 power of 5 joules. Alright, that's all for now. We will continue in other episode with another exercise informative 4.4. Right, see you next time. Bye. Assalamualaikum.